Hello everyone and welcome to today's class. It is our second and last lesson on the topic equilibrium and center of gravity. So as usual, let me comment by giving you the quote of the day, which states that these 5 words have killed dreams of many people in the world. So be careful not to join the queue and be one of the victims. So these 5 words are, what will other people say? So we'll discuss that quote at the end of our class today. So today we'll be discussing about the states of equilibrium and stability. So first of all, we need to define what we mean by the terms equilibrium and stability. So remember, the word equilibrium is just coming from the word equal. So equilibrium refers to the state of balance of a body. So equilibrium simply refers to the state of balance of a body. Then stability refers to how easy or difficult it is for an object to topple over when a force is applied to it. How easy or difficult it is for an object to topple or to fall over when a force is applied to it. Now there are 3 states of equilibrium. So 1, we have what we call stable equilibrium. 2, we have what we call unstable equilibrium, and lastly we have what we call neutral equilibrium. So let's discuss these 3 states of equilibrium. So let's start with the stable equilibrium. So when do we say that a body is in stable equilibrium? So in stable equilibrium, this is whereby an object will hardly tilt over when a force is applied on it. So we are saying that stable equilibrium, this is whereby an object will hardly tilt over when a force is applied on it. Then also in stable equilibrium, the position of center of gravity is very low and below the base of the object. So the position of COG is very low, is as low as possible and below the object. Then the vertical line drawn through the position of center of gravity falls inside the base. Then when the object is slightly pushed. So we are saying that the 3 conditions that categorize a state of equilibrium, stable state of equilibrium, is that is for an object to be said to be in stable equilibrium, it must meet these 3 conditions. 1 is that an object will hardly tilt over when a force is applied on it. 2, the position of center of gravity must be as low as possible, that is below the base of the object. And 3 is that the vertical line through the position of center of gravity falls inside the base when the object is slightly pushed. So like for this case, I have my cone here. When I slightly push it, that is in the direction shown, actually the vertical line through the position of center of gravity does not fall outside the base. That is, the vertical line through the position of center of gravity still falls within the base. That is when the object is slightly pushed. Then examples of objects in stable equilibrium is a Bunsen burner resting on its base. So the base of a Bunsen burner is usually very broad, such that the position of center of gravity is as low as possible and actually the base area is as broad as possible. Then the second example of an object in stable equilibrium is a cone resting on its base. That is like for this case here, if this is my surface, then I have my cone resting here. So in this state we say that it is in stable equilibrium. So we are saying that, why? Because even when I push it slightly, actually the vertical line through position of center of gravity falls within the base. So we are saying that for an object to be in stable equilibrium, that is, a stable equilibrium is where an object will hardly tilt over when a force is applied on it. Then the position of center of gravity is as low as possible and below the base of the object. Then the vertical line through the position of center of gravity falls inside the base when the object is slightly pushed. Then examples of objects in stable equilibrium is a Bunsen burner resting on its base. Then 2, a cone resting on its base. Then we look at the second state of equilibrium, what we are calling the unstable equilibrium. So when do we say that an object is in unstable equilibrium? So unstable equilibrium, this is where an object will easily topple over when a force is applied on it. So we are saying that unstable equilibrium is where an object will easily topple over when a force is applied on it. Then the position of center of gravity is high and far from the base. The position of COG is high and far from the base. Like for this case, the position of center of gravity could be somewhere here. Then when I apply a smaller force on this object, it actually falls over, or it topples over. Then a small sideways push causes the vertical line through the COG to fall outside the base. Like for this case, I have my vertical line here, but when I apply some smaller force on this particular object, the vertical line falls outside the base. So like for this case, this is the base, because this is what is supporting this particular cone on the surface. So for unstable equilibrium, when a small force is applied on the object, the vertical line through the position of center of gravity falls outside the base. It falls outside the base. Then examples of activities where an object is in unstable equilibrium is in a bus having a lot of luggage on its top. So if you have a bus having more luggage on the top, it means when we have a smaller force acting on it, actually the bus will fall off, or it topples over. Why? Because the vertical line through the position of center of gravity actually falls outside the base. That is when a smaller force is applied on it. Then the second example of an object in a stable equilibrium is a cone resting on its thin top end. Like for this case, I have my top end here. So if I have my cone resting on the surface on its top end, actually because the area of the top end is very small, it means the vertical line easily falls outside the base. So a cone resting on its thin top end. So we are saying that unstable equilibrium is where an object will easily topple over when a small force is applied on it. Then also in unstable equilibrium, the position of center of gravity is as high as possible and far away from the base, maybe somewhere like here. Then a small sideways push causes the vertical line through the position of center of gravity to fall outside the base. Yeah, like for this case, a small push causes this line to fall outside the base. So in such a state, we say that the object is in unstable equilibrium. Then example is a bus resting a bus with a lot of luggage on its top, then a cone resting on its thin top end. Then 3, we look at neutral equilibrium. That is our third state of equilibrium. So when do we say that a body is in neutral equilibrium? So neutral equilibrium, this is where the position of center of gravity is in the middle and the object can just roll over without changing the position of center of gravity. That is, the position of COG is in the middle of the object, such that when you apply some smaller force or even a larger force on the object, it can just roll over. But actually the position of COG, because it is in the middle, it cannot change. So in neutral equilibrium is where the position of center of gravity is in the middle and the object can just roll over without changing the position of center of gravity. Examples of objects in neutral equilibrium is a marble. So for a marble, you can just when you push it slightly, it can just move through some points, but actually you cannot change the position of COG because it is in the middle. Then another example of an object in neutral equilibrium is a ball on the ground. So if you have a ball on the ground, when you kick it, it can just move from one side to another, but you cannot change its position of center of gravity. So it can only move from one point to another, but you cannot change the position of center of gravity because the COG is already in the middle of that particular ball. So most spherical objects will actually fall under neutral equilibrium. So in short, or in summary, we have said that we have 3 states of equilibrium, that is stable, unstable, and neutral. Then the main differences between the 3 states of equilibrium is that, one, let's start with the stable equilibrium. So we have said that for stable equilibrium, the position of center of gravity is as low as possible and below the base. Then when a small force is applied on the object in stable equilibrium, is applied on it, actually the object can just sway from side to side. That is, the vertical line through the position of center of gravity still falls within the base. Then we have talked of unstable equilibrium. We have said that for unstable equilibrium, the position of center of gravity is as high as possible. That is, high above the base of that particular object. Then the vertical line easily falls outside the base when a smaller force is applied on it. Then you have said that for neutral equilibrium, the position of center of gravity is at the middle of the object, such that the object can just roll over without changing the position of center of gravity, that is when a smaller force is applied on it. Next, we look at the factors affecting the stability of an object. So we have two main factors affecting stability of an object. One is the area of the base and two is the position of center of gravity. Now the question is, how does the area of the base affect the stability of an object? So if the base area is large, then the line through the center of gravity of the body remains within the base. That is, even if the body is tilted through a very large angle. So if a body is in stable equilibrium, then it means that if the base area is actually large, then it means that the line through the position of center of gravity of the body remains within the base, even if the body is tilted through a large angle. Therefore, a body with a broader base is more stable than a body with a narrow base. So we can easily conclude that the larger the base area, the more the stability of an object. Or we can simply say that the base area is directly proportional to the stability of an object. So like for this case, the base area is large, therefore this object is very stable, or its stability is high. For this case, the base area is very small, therefore this object is less stable, or its stability is very low. So the base area is directly proportional to the stability of an object. Then the second factor is the position of center of gravity, or what we are denoting by the COG. Now, how does the position of center of gravity affect the stability of an object? So a body is more stable when its position of center of gravity is as low as possible. So the lower the position of center of gravity, the more stable an object will be. Then this can be achieved by making the base to be heavier. Then bodies with high center of gravity are less stable. Yeah, for example, if you are fighting with someone who is very broad, you realize that it is very difficult to make that person to fall down on the ground. Why? Because when the person is very broad enough, it means their base area is large, and when the person is broad and at the same time short, it means also their position of center of gravity is as low as possible. So if the person is broad and his position of center of gravity is also low, it means that person is very stable. That's why it becomes difficult to make such a person actually fall down. So we are saying that the lower the position of center of gravity, the more the stability of an object. Then the higher the position of center of gravity, the lesser the stability of an object. Therefore, we can easily conclude that the position of center of gravity of an object is inversely proportional to the stability of an object. Then we look at the application of stability. Now, where do we apply stability in real life situation? So the first application is in motor industries. So the first application under motor industries is that buses are made more stable by having light materials for the upper parts of the body and the heavy chassis and the engine as low as possible, and also the luggage compartments are situated in the lower part so that the position of center of gravity is as low as possible. So you look at most buses, they will have the engine, that is the heavier parts, the engine and the chassis situated as low as possible. Then also the luggage compartments are made at very low, that is closer to the wheels. That is when the engine is heavier and it is low, it means they are broadening the base area. So the broader the base area, the more the stability that particular bus will be. Also, we have other buses which we call the double deckers. It is not allowed for passengers to stand in the upper decker of a double decker. Why? Because when you stand in the upper decker, it means you are increasing, you are making the upper part to be heavier. Therefore, the base area becomes less stable. The base area becomes less broader. Thereby, it means you are increasing the position of center of gravity of that bus and therefore making it less stable. So if it is the customers or the passengers should sit in the upper decker of a double decker bus, that is to lower the position of center of gravity, therefore making the bus more stable, thereby reducing chances of accidents. Then also the second application that is under motor industries is that racing cars, they have low position of center of gravity and wide tracks, which allows a large angle of tilt. Hence, it can negotiate sharp corners at high speeds without toppling over. So if you've looked at racing cars, they usually have very wide wheels, which are of course very low. So the wheels are wide and low to increase the base area. So the larger the base area, the more the stability of those racing cars. Then again, those cars, they also have they are made very low. They are usually very shorter. They are very low, in fact closer to the ground. So the lower they are made very low so that to reduce the position of center of gravity, thereby also increasing the stability. Then the second application of stability is in areas of support. So the first of application in areas of support is that to alight from a moving bus, that is to move out from a moving bus, a person has to spread out his legs. That is to increase the area of support. So when you spread your legs, it means you are broadening the area, thereby increasing your stability. Remember, the larger the base area, the more the stability, like for this case. Also, when you are spreading out your legs, it means you are reducing your height, thereby reducing your position of center of gravity. And the lower the position of center of gravity, the more stable actually you will be. So to alight from a moving bus, a person has to spread out his legs to increase the area of support. So this also helps in lowering the position of center of gravity, thereby increasing stability. Then the second application under the areas of support is that a person carrying a bucket of water in one hand has to lean or bend his body to the other side so as to adjust his position of center of gravity. So when you are leaning, you are reducing your position of center of gravity, thereby the lower the position of center of gravity, the more stable you will be. Then the third application is that a Bunsen burner, it has a wide heavy base. So the heavy base actually lowers the position of center of gravity, and the large base area also provides a large angle of tilt, thereby before toppling. Therefore, a Bunsen burner, it has a wider base to increase the position of center, to lower the position of center of gravity and broaden the area, thereby increasing stability. Then the last application is in chairs, stools, tripod stands, tables are provided with 3 or more legs. So the legs are made in such a way that they slightly incline outward to improve stability. So when they incline outward, it means they are broadening the base area and also reducing the position of center of gravity, thereby increasing their stability. Lastly, we look at an example involving stability. So we have the figure below shows a uniform meter rule pivoted at the 30 centimeter mark. It is balanced by a weight of 2 Newton suspended at 5 centimeter mark. So we are required to determine the weight of the meter rule. So the most important thing to note here, that is under the equilibrium and center of gravity, is that the weight of an object will always act at its geometric center or at the midpoint. So if we are talking of a meter rule, remember a meter rule, it means the total length is 1 meter or simply 100 centimeters. Therefore, the weight of that object will act at the 50 centimeter mark. That is the midpoint of 100 centimeter mark. Then we are also told that the figure below shows a uniform meter rule pivoted at the 30 centimeter mark. It is balanced by a weight of 2 Newton suspended at the 5 centimeter mark. So determine the weight of the meter rule. So the most important thing is to note that the weight will always act at the midpoint. So if it is a meter rule which is 100 centimeters, then the weight will act at the 50 centimeter mark. If it was half meter rule, which means its total length is 50 centimeters, then the weight will act at the 25 centimeter mark. So that is the most important point to note, that the weight always acts at the midpoint or at the where the COG will actually be at. So as usual, from the principle of moments, actually clockwise moments must be equal to the sum of anti-clockwise moments. So we did say that clockwise moments are provided by the forces which causes the bar to move in the clockwise direction. So like in this case, my clockwise moment will be provided by the weight. So because this is the 30 centimeter mark, therefore the 50 centimeter mark will be somewhere here. So the weight will cause the bar to move in this direction, that is relative to the pivot. So this direction is actually the clockwise direction. Therefore we are saying that the weight will constitute the clockwise moments. So if we take the force times the perpendicular distance of that weight from the pivot, it will give us the clockwise moment. So it will be the force due to the weight, then times the perpendicular distance, that is from the weight, from the pivot to actually the weight. So we have 50 minus 30, so that will be the perpendicular distance of the weight from the pivot times the weight, that will give us the clockwise moment. So we have F, force due to the weight, times perpendicular distance of the weight from the pivot, must be equal to, and the clockwise moments, we only have this force because it will cause the bar to move downwards, therefore it is an anti-clockwise moment. So its force times its perpendicular distance. So F of 2 Newton force times perpendicular distance of the 2 Newton force will give us the anti-clockwise moments. So if I substitute the values, I have the force due to the weight, which is W, so Fw times the perpendicular distance of the force W from the pivot is actually 50 centimeters minus 30 centimeters, that is this distance. But because the length has to be in meters, therefore it means we'll convert them from centimeters to meters. So we know that 100 centimeters is equals to 1 meter. What about 50 minus 30 centimeters? So we divide by 100, then you will get 20 centimeters. So divide by 100, you actually get 0.2 meters. So this will be equal to the force due to the 2 Newton is actually 2 Newton times the perpendicular distance of the 2 Newton force from the pivot is 5 minus 30, that is this distance. So 5 minus 30, then to convert it into meters, we divide by 100. So we have 30 minus 5, which is 25. 25 divided by 100, you get 0.25 meters. So you compute this, we have F times 0.02 is equals to 2 times 0.25, then divide by, so I'm making F the subject of the formula by dividing both sides by 0.2 by 0.2. So we have 2 times 0.25 divided by 0.2. So Fw, which is equals to the weight, it will give you 2.5 Newton. I have an exercise here which I recommend that students should try to see whether they understood the example that we have just done. So part 1 reads that the figure below shows a uniform meter rule in equilibrium. So determine its weight. So I told you the expected answer is 2 Newton, but just to give you a clue, the weight will act at the 50 centimeter mark. Then this force is causing the bar to move upwards, therefore it will be categorized under what we call the anti-clockwise moments. Then when you are given the mass, you simply find the force. Remember, force is equals to mg, so you convert the mass into kilograms. Then force is equals to mg, mass times gravity, so that will give you the weight due to this force. Also, force is equals to mass times gravity, that is mg. You take the mass times the gravity, you get the force. Then after that, you simply say clockwise moments must be equal to anti-clockwise moments. So the expected answer is 2 Newton. Example exercise 2 reads, the figure below shows a uniform meter rule pivoted and supported as shown. Given that its weight is 30 Newton, find the distance x. So here we have our force T, which is 20 Newton acting upwards. Then also, just to give you a clue, is that here you need to find what we call the weight will act at the 50 centimeter mark. So its weight will act at the 50 centimeter mark. So I forgot to indicate the answer, but you can just work out and see. In case you doubt your answer, just drop a comment over this video on my YouTube channel, and I'm going to confirm whether your answer is correct or wrong. So we've come to the end of our class today, but we need to discuss the quote of the day. So remember, the quote of the day stated that these 5 words have killed dreams of many people in the world. So be careful not to join the queue and be one of the victims. Be one of the victims. So what are these 5 words? So the 5 words were, what will other people say? So the quote simply means, ask yourself, how many times have we stopped doing something great in the world just because we fear what other people will say? So the quote is warning us that we should never allow other people's opinion stop us from pursuing our own dreams. So it is okay to listen. It is okay to listen to other people's opinion and advice, but never ever let their opinion and advice be your final decision. That is, listen to their opinion and advices, then isolate the positive advices and opinions from the negative ones, then use the positive opinions and the positive advices that you have isolated from the negative ones to make your final decisions. Then what others will say about you does not matter. Instead, what matters to your life is what you say to you about yourself. And also remember that sometimes the things you end up hearing about yourself from others are the things you've said about yourself to others. So no one will believe in you unless you believe in yourself first. And lastly, the richest place in the world is the graveyard or the cemetery. Why? Because in the graveyard you will find dreams that were never pursued, you will find books that were never written or published, you will find knowledge that was never shared, you will find comedy that was never performed, you will find dreams, you will find drama that was never acted. So from this minute, live your life fully so that you will die empty when your time comes. This is Kind Tuition Academy. Kindly hit that subscription button on YouTube. Thank you.